So for number 7, it says the following for the following reaction, our delta H prime, or delta H0 naught, is negative 74.8 kilojoules, and our delta S naught is negative 80.7 joules per Kelvin. We need to find our delta G naught at 25 degrees Celsius. And we have to figure out if this reaction is spontaneous at this temperature. And if you remember to find out if it's spontaneous or not, our delta G has to be less than 0 or negative. If delta G is positive, it's going to be a non-spontaneous reaction. So in our reference booklet, there's a formula. Our formula is delta, let's see, where was I? Okay. Delta G, not delta H, is equal to delta H times our temperature in Kelvin, it's got to be in Kelvin, times our delta S. And we can have each of those, right? So our little knots up there. So we've got our delta H, we've got our delta S, and we've got our temperature. Let's change that temperature to Kelvin. So we're going to add 273, not 2.73. Let's see. So that's going to give us 298 Kelvin. So delta G is equal to our delta H, which was negative 74.8 kilojoules per, and then our temperature, 298 Kelvin. I'm sorry, that's not times, that's plus up here. So a little plus there. Times our delta S, which is going to be negative 80 joules per Kelvin. Our Kelvins are going to cancel out. And when we do this, the trick here, the issue that we have to pay attention to is that this is in kilojoules, right? And this is in joules. So we have to convert one to the other. I solved this problem and I left it in kilojoules. So this answer here, when we multiply those two together, the kelvins are going to cancel, and we have to divide that answer by 1,000 to get these joules into kilojoules. So then once I add these two together, I'm going to end up with negative 50.75 kilojoules. If you converted it, if you converted the kilojoules to joules, then we would just multiply our answer by 1,000. The issue here is it spontaneous? Well, we have a negative delta G. And that negative delta G indicates that, yes, this is spontaneous.